Hello and welcome. I'm Dr. Matthew Rasmussen, and in this series of slides I'm going to describe the distinction between cause and effect. Essentially, this is going to wrap up the entire description of an independent variable and dependent variable. So what is cause and effect? Well, a cause is essentially what made the outcome appear. In other words, the cause is what made something happen, what made the change. And the effect is actually going to be the outcome. Okay? This is going to be the outcome from a cause. Let me give you an example. So Matt punched his brother Zach. His eyes began to tear up, and then Zach wept profusely. So what is the cause and effect in this situation? Well, sometimes I like to start from the effect and then work to the cause. Sometimes it's a little bit more simple. So what is the effect? Well, the effect is the outcome is Zach crying. Well, that's very, very easy. The outcome is that Zach began to cry. So we know that the effect was Zach crying. What was the cause of that behavior? What was the cause of that outcome? Well, that was obviously the punch. So establishing cause and effect in this situation is simple. We have the effect being the crying, and the cause of that crying was from the punch. So we can determine cause and effect very, very simply. Another example. For 30 years, Bobby smoked 2 packs of cigarettes per day. At the age of 50, Bobby was diagnosed with lung cancer. So what is the cause and effect for this example? Well, again, let's start from the effect. The effect was the outcome, and that outcome was lung cancer. So we know what happened to Bobby in the end. He was diagnosed with having lung cancer. Now, what is the likely cause of this effect? Well, that is the cigarette exposure. Now, yes, it could have been anything. It could have been the job that he worked. He could have had a genetic predisposition. However, it is very, very likely that the cause of his lung cancer was from the cigarette exposure. So again, cause and effect can be demonstrated here in that the cigarette exposure is the cause and the lung cancer is the effect. You may be curious why it is important to establish cause and effect in an experiment or in general. Well, it's important for many reasons. The most important reason is that it provides evidence for the cause. So when you specifically determine the cause and effect, you know exactly what caused the effect, and that was the manipulation. So here are a few examples of what cause and effect can be important for. So we know that fluoride protects your teeth by reducing cavities, and researchers have found this out via vast amount of experiments. Yes, more than likely many of them occurred on animals, but many of them also occurred on human beings. And through this cause and effect, researchers were able to establish that fluoride is the cause of the reduction in cavities. Smoking cigarettes has been linked to cancer. And this is, again, important cause and effect to be able to determine, because prior to this research, prior to this evidence, individuals didn't know that smoking cigarettes was dangerous. Just imagine if we didn't know that cigarettes were the cause of the effect, and that effect is cancer. This would be terrible. We would think that, oh, maybe it's, something completely different. It's the sun that is causing the cancer. It is the food that we eat that is causing the cancer. It's the way that we talk that's causing the cancer. No, it's not. It's the cigarettes that people inhale. That is the cause of the effect. And that effect, again, is cancer. Another perfect example in that cause and effect is so essential to demonstrate is that individuals once believed, not too long ago actually, and actually many individuals still maintain this belief, that vaccines, primarily the measles, mumps, and rubella vaccine, given at a very, very early age to a child, that is the actual cause of the developmental disorder labeled autism. And through experiments recently over the last 10 years, it doesn't necessarily seem to be that is anywhere near the cause of autism. And so it was once believed that vaccines was the cause of the effect by some individuals. It's no longer necessarily even in any sort of community taken for to be the truth. And therefore, the cause and effect have essentially been ruled out, that the cause of the effect was not vaccines. So cause and effect is very, very important to determine, And here's just a few pieces of evidence. So now that we know what cause and effect is, and we know the importance for cause and effect, well, how can a researcher establish cause and effect? Well, researchers establish cause and effect in a few different ways. One way is through manipulation. A researcher needs to have an independent variable, and that independent variable, again, needs to consist of two conditions: the experimental condition and the control condition. The control condition allows for comparison to the experimental, and that allows the researcher to determine cause. Now, the effect needs to be measured, and the effect is measured via some sort of variable, and that is the dependent variable. So those two variables are absolutely crucial: the manipulation and the measurement, the independent variable and the dependent variable. Now, there's two other terms as well. First one is random assignment. This is another key term that is important for an experiment and important to determine cause and effect. What random assignment is ensuring that everyone that could be in the experiment and will be in the experiment, that any one of those people could be subjected to either the experimental condition or the control condition, in that everyone who is going to be in the experiment could be subjected to either of those levels, the experimental or the control. It's not like the first few people get the experimental and then the last few people get the control. There's going to be random. That is random assignment. I will demonstrate this with an example in a moment. Experimental control. Experimental control is absolutely crucial to an experiment, and this is what probably many people know has just been a controlled experiment. A controlled experiment is one that does not have any outside sources that could be influencing the data in any sort of manner. So this is that all factors other than the IV are held constant, and they're held constant throughout conditions. So the experimental condition and the control condition are nearly identical. The only thing that differs is that manipulation. So in an example, we will see that there is only one slight deviation from the experimental to the control, and that is called an experimental control. Together, those four pieces allow researchers to establish cause and effect. Let's take a look at an example. This is an example of random assignment that has not been properly put into place, and I'd like you to determine where this lack of random assignment exists. So here's the example. Fred gave the first 15 students who walked into his class a study guide, whereas the next 15 students who walked into his class received nothing. The students who received the study guide performed better on the test than those who did not receive the study guide. Was the study guide a success? Well, some might say that yes, the study guide was a success. However, the study guide may have not been a success, and we'll explain that in just a moment. So first off, the independent variable. Yes, there was absolutely an independent variable, and that was whether the study guide was provided to the students or not. So a study guide was the overarching independent variable, and the two levels was yes and no, the experimental and the control. Great, it passes that test. There is a comparison. The dependent variable, absolutely. That was the test score. So the manner in which they scored on a test, that is the dependent variable. So we have a potential cause and we have the potential effect. So we have both of those. However, can we determine cause and effect from this? Well, it may not be so likely. However, yes, we do. Just to look at control, we do have control here, and that it was from the same exact class, the same exact times. They were, possibly the same students, or were they? Well, they may not have been, because random assignment wasn't in place. Well, why is this? Well, this is because the first 15 students received the study guide, and the last 15 students did not receive the study guide. So, is the study guide really making the effect? Is the study guide really the cause here? What are the other potential causes for this effect? And the effect, again, is that there was a change in how some students performed on the test. What could that cause be? Well, it may not necessarily be the study guide. It could be essentially that the first 15 kids who walked into the class, they were the more brighter students, whereas the 15 kids who walked in after them, they weren't as bright. Possibly the first 15 students, they were the students that studied. The last 15 students, they failed to study. So there's many alternative answers for such a situation, and therefore random assignment is absolutely crucial. And what would a random assignment look like here? Well, that would be that the first student who comes in gets the study guide. The second student, they do not receive the study guide. Third student, they receive the study guide. Fourth student does not. In some sort of fashion like that, that will control for random assignment. So it's important to always remember to try to find a potential problem with experimental control. And it's very easy to find a lack of experimental control. Basically what you need to look for, again, is when both conditions differ drastically more so than just by the independent variable. And so when an independent variable is not held constant and an alternative variable is introduced into the experiment, well, that alternative variable is considered a confound. And a confound is a third variable that comes into play here that actually is likely, or potentially likely, causing the effect. So what a confound is specifically, a great definition, is that it is the factor the researcher is not manipulating or keeping constant, and this is actually causing the effect. So let me give you an example. This is the fluoride and toothbrush example. The fluoride was delivered on an electric toothbrush, whereas the non-fluoride toothpaste was delivered on a non-electric toothbrush. So here the independent variable was supposed to be just the presence of fluoride in toothpaste. However, as you can see, there was a lack of experimental control in that if the individual is measuring the ability of fluoride at protecting the teeth against cavities, well, we don't necessarily know if fluoride is protecting the teeth or if it's the electric toothbrush versus the non-electric toothbrush. So what a researcher needs to do is to maintain experimental control. And what would this look like? Well, this would look like fluoride versus non-fluoride both on an electric toothbrush, or fluoride versus non-fluoride on a non-electrical toothbrush, to make sure that everything is same, so that all the bases are covered and that experimental control has been maintained. And this is going to help ensure cause and effect. Let's get on to the last example of this lecture. This is where there is actually no clear independent variable. And having no clear independent variable, this is going to segue again into the next series of slides on correlation. Okay, and so here's the experiment. Jim is interested in how clothing influences a person's athletic ability. He asks participants how many articles of athletic clothing they own. He then compares that score to their ability to jump, run, and climb. As Jim hypothesized, people who own more athletic clothing can jump higher, run faster, and climb higher than people that own less athletic clothing. Jim then advocates for a full closet of athletic clothing in everyone's house. Is this the right thing to do? So, what did Jim do here? Did he run a great experiment, or did he run an experiment that was lacking some sort of quality that will offer him cause and effect? Well, for sure, he had no clear independent variable. However, he did have a dependent variable, and what he did is he did measure some sort of variable. He measured 3 variables, in fact. He measured the ability to jump, the ability to run, as well as the ability to climb. However, the problem was that independent variable, and that there was no clear manipulation. No manipulation whatsoever. He did not manipulate the groups. He did not assign individuals into one group and individuals into the other group. So there was no assignment into an experimental condition versus a control condition. So what could this confound that be that could be incorporated here into this experiment? What confound could Jim have been falling victim to? Take a moment to think about that and pause it. So the confound that Jim was likely falling victim to was that people who just are athletic, they own more athletic clothing than people who aren't. And it's not athletic clothing that actually causes a person to be athletic. It's just the individuals who are athletic, they own more athletic clothing. Like a sports player, person who plays hockey, they're going to own some some sweatshirts, some soft pants, things along those lines. Basketball player, they're going to probably own warm-ups. Soccer player, they're going to own the socks, they're going to own the materials, right? So all of these athletes, they're going to own those things. They're going to probably wear those things around. Whereas these other individuals who aren't athletes, well, they're not going to wear them, okay? So in this aspect, clothing does nothing for an individual. Now, if that was the case, if clothing actually made people more athletic, people would be buying all sorts of athletic clothing. And I know that this may seem like this in reality, that people would like to just go buy something and it makes them that. Well, it doesn't, okay? These things that you have, they don't make you it. This is just some sort of confound that is coming into play. Now that we know what cause and effect mean, we know why they're important, we also know exactly how they can be found in an experiment. Why don't we wrap it up? So, to wrap it up, there are 4 important aspects for cause and effect to be in an experiment. The first key is that there has to be manipulation for there to be cause and effect. There has to be a clear and definitive experimental group, as well as a comparison group, essentially the control group. There has to be a measurement, and this is the second key, is that there has to be some factor that is measured, and that, again, is the effect. So again, you have the cause and the effect. But now, to ensure that cause and effect actually worked properly, the researchers need to ensure random assignment, and that is anyone in the experiment could have been assigned to the experimental group or the control group. And then experimental control is just ensuring that all of the factors that are in the experiment, they are completely controlled for except the manipulation. The manipulation is the only factor that depends on the condition that it's in. So for experimental condition, there is one set of stimuli, and possibly for the control condition, there's another set of stimuli. So that is the only thing that is altered. Again, we've discussed what a confound is. A confound is a variable that is coming into play, oftentimes underneath the researcher's nose, and they are unaware of it, but this is actually the variable that could be causing that change, causing that effect. So this could actually be the cause of an effect, and that's not what the researchers want. The researchers want the cause to be because of the manipulation. Now, this essentially, especially that last example that was described here, this is essentially leading an individual into the correlation research. And what a correlation means is a relationship between 2 variables. And this is going to be a very, very important theme, because this will allow you as well to really understand what an experimental method is, which we've been going over: the independent variable and the dependent variable, the random assignment, the experimental control, what a confound is, what that material is, versus just being able to determine that, well, 2 things are linked together. That'll be talked about further in the next lecture. So please tune in then. Thanks and have a great day.